If you're working on language models like OpenAI's ChatGPT or Meta's open source LLM Llama, and you want to build powerful AI applications, you've probably come across LangChain, LangGraph, LangFlow, and LangSmith. But how do they differ? And which ones should you use? I'll explain everything you need to know with examples. In this video, we'll explore each technology, how they differ, compare them with each other, and also answer the most common questions developers have. By the end of this video, you'll be clear on which one fits your needs the best. If you're interested in learning how to build modern agentic solutions at scale that are production ready, consider subscribing to this channel and hit the bell icon so that you don't miss any updates. Let's get started. Let's talk about LangChain first. To better understand LangChain, we'll do an overview of the key components LangChain provides to you. In our example, we want to build an application that will use our preferred OpenAI GPT model to generate an initial response. Use the current version of Llama to refine that response. Have an agent that decides whether to fetch external data or to generate a response on that query. And then store previous interactions with the user. LangChain provides pre-written libraries that make building agentic applications infinitely more simple. Without LangChain, you will need to manage all of these components and write lots of code to handle that logic, API calls, and memory. This is how I built my first agentic AI application. It's cumbersome and unnecessary. Now, here's a high level of how the code would look like, the wrong way. I wrote a function to make the API calls to ChatGPT, called Llama, created my own memory database in the form of a relational database, built the logic to manage it, and wrote my own code to manage my agent tools. You can see the challenges with this approach. There'll be lots of boilerplate code. I will need to manage all the API calls and manually code the agent's decision-making process. As the logic grows more complex, the code becomes harder to maintain and scale. That's where LangChain comes into the picture. LangChain is an open source framework for building applications powered by language models. It helps developers chain prompts, interact with external data, and build applications to remember context. Let's begin the breakdown with key features that make LangChain so powerful. LangChain supports almost any LLM, whether it's a closed source model like ChatGPT or open source models like Llama. Just plug in your API key or run it locally. Prompt templates. LangChain includes prompt templates so you don't need to hardcode any queries. You can customize prompts dynamically for different tasks. Chains. Chains are at the heart of LangChain. You can connect different tasks like calling an LLM, retrieving data, and processing responses into one seamless workflow. Indexes. LangChain lets you use indexes like document loaders and vector databases to pull in external data so your models aren't limited to what they're trained on. Memory. LangChain enables your applications to remember past interactions, adding long-term memory to your workflows. Agents. These components use the LLM as a reasoning engine to decide into the next steps in the workflow, making your application more dynamic and responsive. So in our example, here's the code and how it would look like with LangChain. First, you'll import LangChain, then use the memory class to create and update memory. Then use the agent class and create agents, and the sequential chain class to connect various functions into a single flow. Next, let's talk about LangGraph. LangGraph is built on top of LangChain to manage agents and their workflows. This library enables developers to create agents and multi-agent workflows. It's open source and free to use. So how is it different from LangChain then? Well, LangChain is great for prompt chaining. LangGraph excels in handling multiple agents and more structured workflows. If you're building a system where multiple agents interact to solve complex problems like task automation or research assistance, you should consider using LangGraph. LangGraph has the concept of a graph with three core concepts. State, a shared data structure that represents the current snapshot of the application. It maintains information that can be updated and accessed by different parts of the graph. A typical state might include user inputs, agent outcomes, and a list of actions taken throughout the workflow. Nodes represent the individual components or actions within a graph. Each node can perform a specific task, like executing an LLM, running functions, or interacting with external tools. Edges. Edges connect nodes and define the flow of execution within the graph. They determine how data moves from one node to another. This is not a directed graph. Nodes can decide which nodes to call next, and they can communicate back and forth. You can use LangGraph when you need to create agents that require cyclical interactions and decision-making processes. It's also ideal for scenarios where multiple agents need to collaborate and work together. So using LangGraph is straightforward. Download the package, import into your projects, and start using the provided classes. All right, next, we're going to talk about LangFlow. Imagine building an AI-powered application chatbot or data processing tools without having to write code. LangFlow makes this possible with its drag-and-drop interface. LangFlow is built on top of LangChain and provides a visual interface to build and experiment with LangChain flows. It's perfect for prototyping LLM applications, allowing users to quickly design workflows, chains, and agents and test them. LangFlow is great for teams looking to create minimal viable products quickly. LangFlow can be installed 3 different ways: as a Python package with LangFlow OSS, as a standalone desktop application with LangFlow Desktop, currently available to Mac OS users at the time of recording this, or as a cloud-hosted service with DataStax's LangFlow. You'll find all the setup instructions in the LangFlow documentation. Whether you decide to host it locally or in the cloud, you'll be able to access the UI where you can drag and connect various tools and services to create full AI workflows. You can then trigger this workflow using APIs from anywhere else. All the API usage info is in the LangFlow documentation. Links are in the description. All right, and finally, let's talk about LangSmith. Building your LLM-based application is one thing. Deploying, testing, and monitoring it to make sure agents and LLM calls are working properly is another thing. That's where LangSmith comes in. LangSmith is designed to assist you at all stages of the LLM application's lifecycle, from prototyping to beta testing and production. While LangChain helps you build applications, LangSmith ensures those applications perform well by offering monitoring evaluation tools, tracing, token usage tracking, error and latency analysis. Free and open source alternatives include Llama Fuse and Phoenix. LangSmith is independent, so you don't need to use LangChain to use it. It works with any LLM framework, including LangGraph. To use LangSmith, install LangSmith package, import it into your project, set up 2 environment variables, start logging traces from your applications using @traceable annotation. LangSmith will collect traces in the LangSmith dashboard. You'll see details like how many tokens were used, how many API calls were made, total cost, error rate, and latency trends, and more. I'll link the video from LangChain in the description if you want more details about LangSmith's features. I hope my video gave you a lot more clarity on which tools are meant for what and when to use each in the Lang ecosystem. If you found this video helpful, please like and subscribe for more content like this. If you want me to create a video on a particular topic, let me know in the comments. And thank you for watching.